I am thrilled, and it is my pleasure to introduce you to our guest speaker today, Pedram Mokrian. Pedram, in this webinar, will describe why AI has become such a high priority and how business leaders can think about developing and adopting AI solutions. He will provide an overview of the key AI terms, concepts, trends that inform business strategy. Along with advising companies around the world on entrepreneurship, business model disruption, and technology innovation strategy. Pedrum teaches courses at Stanford through the School of Engineering, and he teaches the XDGT 224, Building an AI-Enabled Organization course, which is part of the Stanford Digital Transformation Program. Before we begin, for our audience, please remember, you can enter in a question at any time, and we do encourage you to submit your questions earlier during this webinar. With that, I'm going to hand the webinar over to Pedram. Pedram, welcome and thank you for being with us today.
Well, thanks so much for having me. It's a delight to talk about one of my favorite topics, and it's strange, even though I'm not a computer scientist and I'm not classically trained in AI itself, for me to not only teach a course on the topic, but to even come and speak to you all about it. So I just wanted to start by giving you a bit of a background as to what is my relationship with AI and how it all came to be. Back in the day, a long time ago, I used to be a chip designer. In fact, my focus was on computer architecture. And it was fascinating to understand how computers work. And it's really interesting also to then start to think about how do you apply that context to how the world works and how the world operates. And so in fact, how I got into Stanford for graduate school in the first place was predicated on my desire to apply, at the time, what were called evolution-based algorithms to risk management and to asset pricing. And so it was taking an engineering approach to think about how markets actually operated. Now, if you think about that context, this is going back a couple of decades now at this point, aging myself. The interesting thing was the world of AI as we know it today and machine learning and all the different models that are being used in practice weren't as prevalent. And so it was still viewed with some skepticism around this notion of this dark art and this dark science or of AI and machines that can kind of think on their own to help with how the world actually operates. Many years later, I actually stepped into the world of venture capital. And that's really when the art of AI was getting implemented deeply inside of a lot of new and emerging technology companies. And one of the most fascinating ways to understand how AI gets applied is to view it through the lens of an entrepreneur. People that have an understanding of what the technology can do and are thinking about how to solve problems, specifically in the greater good of the world, to take these innovations and these concepts, productize them, and then take them to market. So a lot of what I'm going to share with you is not only what I've seen and what I've dealt with from an entrepreneur's perspective as an investor, helping them understand how to create these businesses, but also at the other side of things, as Anita pointed out, I also advise a number of large companies and helping them understand how can they start to then incorporate some of these technologies into their practice on a daily basis. So without further ado, I'm going to dive in to our topic of discussion today, which begins with a big overview of this notion of data and AI. And the first thing that I wanted to say is the reason that I got excited about putting this course together in the first place is because I was seeing this divergence of conversations happening in the world of AI. There's a lot of people that were technologists that were talking about the deep technologies and the emerging algorithms of AI and how they can put that to practice and to use. So think about this as being sort of an AI ecosystem driven by technologists speaking to technologists. And sometimes that's not very useful for people that are trying to get an understanding of what's going on. On the other side, there's people that are talking at it at such a high level that it's almost like a very, very big macro view, but you really don't know how these technologies get applied to that because, there's a huge gap in terms of that understanding. And so the course itself is really driven around giving you a perspective that's not so entrenched and ingrained in terms of the technology itself, but it's not just a very big altruistic view of what AI can do either. It's really about a practical understanding of what it means, and some technical terminologies and some examples around how to think about what is the difference between supervised and unsupervised learning, and how can that be useful for you. Well, as a manager or somebody who's leading a project like this, it's always good to at least be well versed in the big picture and then leave the details to the people that are experts. But if there's a disconnect between you not even understanding what it even means to think about supervised learning or how it even works, well, then you're not going to have the good level of empathy to actually be able to drive these projects forward. So, and then the last part of that is going to be focused on the strategy, right? How do we think about that? Which is core to a lot of the things that I do are in and around innovation, which is to just define and describe strategies for things that may appear to be abstract or hard to deal with. So I want to begin with something that I do actually in a lot of my innovation talks, which is talk about this thing called the Dunning-Kruger effect. And for those of you that are familiar with it, you'll recognize the curve. And for those of you that aren't, what I like to do is to frame this in terms of a very simple 2x2 and think about understanding, right, of a human being or an organization. If we don't really understand it at all, right, that's what the x-axis is representing, right, versus we have some experience with a topic or we're experts in a topic. How does that relate to our confidence? What you would anticipate is that something like this is a linear curve, which says, well, the more confident we are about something, then the greater chance of us being an expert in it, and vice versa. The more expertise we have about a subject matter, the more confidence we should have. What the amazing thing about this research was that it unearthed a very interesting pattern, and it actually looks like this. And they did this with a lot of graduate students where at the beginning they had so much confidence and so much excitement, but then the more they learned about the topic and the more that they internalized all that knowledge, even though they're becoming better and better at the topic and the subject matter and becoming bigger experts in it, their confidence was actually dropping. And I actually overlay this in terms of where I think the notion of AI and innovation and bringing new things falls into this danger zone of a lot of organizations. At first, it's ecosystems and people and organizations that know nothing about the subject. They're just very confident because they've read an article, or seen something on TV. Great, take that enthusiasm, but now let's actually bolt on practice and expertise and confidence. The other side of it is organizations that have so much entrenched capabilities, but because they've seen some of the dark side of what can go wrong, they actually end up handcuffing themselves. And they don't have the courage and the confidence to actually go and pursue these things because it might not have worked in the past. And so they're bringing all of those legacy thoughts with them as we go forward. This, unfortunately, is the exact same thing with AI. Because a lot of people don't really understand what it is, it's almost like a dark science, you can basically say, we'll throw AI at the problem and we'll solve it. That gets us into the first bucket. On the other side, because this subject matter has been around for decades, and a lot of times it hasn't actually yielded promising results, a lot of people then also assume that, well, here we go again, and it's not going to work this time either. And it throws us into the middle bucket, where the observations of history are actually tainting what our capabilities are going forward. And it's extremely important as managers to understand where also you are and how to deflect some of the criticism, even though you know that the world has changed, but at the same time, how to temper the enthusiasm when you know, for example, that it's not just around throwing around buzzwords, it's actually about building systems that work. And so hopefully this program gives you a sense of how to think about that. So why is this important today? Well, there's an aspirational goal that a lot of people think about, which is how to become more digital and more digitally enabled, and how to shift towards this notion of being a digital operating company. Now, we've seen this in terms of a lot of tech companies take on this model where you have almost like this nonlinear exponential value creation opportunity that expands with the more data that you have and the more users that you might have, especially in the world of consumer internet, that a traditional operating model only scales in terms of the efficiencies of scale, but not because of the fact that you're actually generating some outsized value because of the data that you're collecting. And so as a result of this, this is where we want to start to then think about how do we take advantage of that underlying data to create this hopefully aspirational exponential value creation opportunity going forward. Which brings us to this term alpha. Alpha is used in public markets and in financial markets to think about an investment strategy that beats the market, right? It's your edge, it's your secret sauce, if you will. It's associated with your ability to create excess returns. And so the way that we want to start to think about this is how can we gain alpha? How can we become better than what the market could typically do based on some unfair advantage and some secret sauce that we might have? And in many instances, this is data. So as we start to reflect back on that exponential value creation opportunity, that effectively reflects that company's alpha, its secret sauce. So if we go back in time and actually look at value creation in general and how companies have historically thought about creating alpha, we've migrated from organizations that view outsized returns being driven by their assets, right? So for example, think about land use rights or the assets associated with factories or stores or real estate. These are physical properties, equipment, inventory, and the like, right? Which effectively gives you the ability to then go and pursue market opportunities because you had those assets under control. Several decades ago, we started to shift that model and we started to say, well, you can also get outsized returns by thinking about intellectual property, right? Which is your unique expertise and your knowledge of the world and how you can actually drive your understanding and your intellect within your organization to then start to drive these outsized returns. And you can think about things like patents, and you can think about things like trade secrets where it comes to things, for example, like manufacturing or chip design, where you have an unfair advantage because of knowledge. As we start to now shift into what a lot of people refer to as the fourth industrial revolution and thinking about data, this is where information is now starting to become your IP of the past, if you will, your unfair advantage to generate alpha. And this is a very, very important process and understanding from a business perspective before we even start to talk about AI. Because one of the underpinning elements of AI, today especially, is your access to data, is your ability to think about how can we actually leverage the data that we have, either access to, the data that we're creating, or the data that we can actually acquire and make use of, for whatever reason that might be, to then make that, as part of our AI strategy, our unfair advantage. How can we use data to drive alpha? And that really is the underlying premise of how we should be thinking strategically around applying AI for business decisions and for business applications. Now, we mentioned this, fourth industrial revolution. We can then overlay that in terms of what has happened historically. Well, what's happened historically is if you go back to one of the most well-studied and oldest ecosystems in the world, namely England, that's been studied, what we've seen here is that the English economy grew linearly with population over centuries. And then something interesting happened, and you can imagine what that is. There is an inflection point. That inflection point started to drive an exponential economy. And this maps up neatly against what we commonly refer to as the industrial revolutions, the first, the second, the third, and now we are in the dawn of the fourth. And this is exactly how we should be thinking about this use of data. So where we went from manual labor, manual work, to mechanized work, right, driven by steam engines and then driven by electricity, and then driven by, over time, more machinery, you started to create outsized returns and outsized capabilities that you couldn't have done otherwise. And then as a result of that, you made the previous generation of doing things, of manufacturing, of procurement, of service delivery, obsolete. This is where we are today, is to think about how can we then take advantage of the tool sets that we have available to us today to continue this evolution. Much the same way that several decades ago, we couldn't even imagine what the internet could be, right? When I grew up, email was just taking off, right? People just, I mean, we literally could have made up any email address on any server because there wasn't that many people using email. Again, I'm dating myself. But now you can start to then imagine, what would the world look like without the internet? How would you even do commerce or conduct any regular business without this notion of the internet available to you? One day soon, we're going to have the same type of conversations around the use of data and intelligence. And so the further we are ahead of that curve, the more strategically placed we'll be to take advantage of all the riches that can come with it. And again, a lot of this has to do with data. So, where are we now? Why are we talking about this digital transformation? There's a confluence of things that are happening simultaneously that are driving this conversation. And sometimes it's just one thing, right? For example, it's electricity, right? But in other times, it's actually a series of things that need to come together exactly at that right time before the value starts to become realized. And when we'll talk about this notion of AI specifically, this subject matter has been around for a long time. And in fact, in the course, we'll talk about a little brief history of it as well. It's been around for decades. But the other elements of this that are really driving this transformative change haven't been. And this is what makes this whole thing so interesting. So the underlying capabilities that we have from computational perspectives and infrastructure, cloud computing, we haven't had this for decades and decades. We haven't had this plethora of data that we have access to for decades and decades. And now, as we start to then think about this broad access of IoT devices, the Internet of Things and sensors and sensor data, and the ability for us to actually generate data from the environment, from our physical ecosystem, becoming unbelievably cheap to the point where it's almost practically free now. All of these are coming now together to create this digital transformation revolution that we're witnessing today. And we're witnessing this not just in the tech ecosystem, we're now starting to witness this across all different domains. And so for just a quick snapshot of what that looks like, there was a recent study by McKinsey & Company that was around how do we even think about the value of AI versus just traditional, analytics that we might have had before. And the incremental value is literally in the trillions of dollars. And as you can see here, it's across virtually every single ecosystem that you can imagine. So irrespective of where you're coming from, you should be thinking outside the box. In fact, in many cases, as I was told recently, you should be thinking without the box. Imagine a world where you can then think about the data and how you can connect that data to value, independent of the fact that you may not be coming from a technology-based company, but you have access to this alpha that you can then leverage. Now, whether it's banking or insurance or pharma or retail, all of these incredibly large ecosystems all stand to gain from the impact of AI. And again, taking advantage of all these different things that are coming together, from cloud computing to data to actually the new technologies and new algorithms that are being created, even on a daily basis in and around AI. So, one thing that you may be thinking of is, I've been throwing around this concept of artificial intelligence and AI for quite some time. What does it mean? How do you define it? It's actually one of the core components and one of the things that I found quite rewarding when I was actually creating this course in the first place is going to people that are truly experts in it and asking them what they think about AI and how do they define it. And you'd be surprised that the definition isn't always as clear as you would hope it would be. There are a few definitions that I will throw at you, and then we'll reserve some of the insights in the course itself. But generally speaking, it's a branch of computer science, right, that deals with intelligent behavior in computers. So it's typically, the way to think about that is how does a computer system perform tasks that are normally require human intelligence to do, such as, for example, visual perception or speech recognition or decision making. And how do we then actually create a mechanism by which the computer can do that instead of the human being? And it's funny, it's one of those things where the more we go back in history, the more we can start to then take things that are daily things that we don't even think twice about, and then apply this definition of AI and then think about, well, would that have been AI back when it was first introduced? And there's a couple of images here I'm sharing it with you from the 1940s, in fact, where this was just common practice on a daily basis, right? You had switchboard operators, you had elevator operators, you had people that were doing these manual tasks that required some level of intelligence to do. And then they were replaced with automation. Think about somebody that picked up a phone that was used to speaking with somebody and saying, I need to speak with Mr. and Mrs. So-and-so, and then they get dispatched to it. Or I need to speak with a certain department and they get dispatched to that because somebody was interpreting that. And now think about that then being replaced effectively with automation. It's magic, right? For somebody that can then just basically say, magically, I got connected to the right person via this notion of automation. And so at the time of adoption, it's very difficult to discern the difference. But over time, we just take it for granted. Now, the other way of thinking about sort of this element of automation as we start to think about this incorporation of AI is also to then understand, more broadly speaking, the spectrum of AI, from narrow to super. And this is where I think a lot of confusion sets in. So what happens in a lot of instances where I speak with business leaders that are not necessarily technologists, and they think about AI, they project onto the conversation things that they've seen in movies, right? These robots that do these magical things, and you can ask them anything about anything, and then they can basically make decisions and unearth the information for you, and stuff happens. But the reality is we actually live in a world of narrow AI today, right? And if you think about something as basic as a Roomba, which I'm sure many of you own, and sometimes you own two of them because they get a little bit smarter over time. This is also AI, right? This is also how we start to then think about AI-powered devices and tools. Now, is this the cutting edge or the bleeding edge? In many cases, it is, right? In many cases, the bleeding edge of AI enables us to do very simple tasks, but to do them in a repeatable, potentially safe way that we couldn't have done otherwise, where we start to incorporate different elements of sensing, different elements of actuation, different elements of potentially decision-making that a very simple device needs to take into account before it can conduct something as basic as wiping popcorn off the floor. So we really need to contextualize, what do we mean when we start to think about AI? We're talking about this very broad definition that we might see in movies that's a little bit outside of the realm of reality? Or are we starting to think about how can we take the things that are ready today and start to then put them to use? And we are really much more closer to this narrow AI world today before we start to then think about generalizing. And so unless you're a technology company, such as like a Google or a Facebook, that basically has entire server farms devoted to this topic and has more data than you can even imagine, it doesn't really make much sense for us to start to think about general AI applications towards traditional business opportunities. And so I don't want to dampen expectations of what is possible today, but unless we can start to then confine and bound our definitions, we're not going to be able to get out of our own way. We're going to be stuck in that first part of the Dunning-Kruger effect curve that I showed you about, where it's all about enthusiasm and nothing about execution. Now, why am I describing all of this? Why are we even talking about AI when we start talking about the power of data to begin with? Well, one of the key things for us to understand is, in order for us to go through this true digital transformation, it means we have to have a greater reliance on data. It's going to be almost like a broken record, so I apologize in advance if I speak about data a little bit too much. But it's true. It's the engine, it's the fuel that makes everything work. Now, the problem that we've had with data is if you rely on it too much, you could draw the wrong conclusions, right? Because you may be looking at it just from a pure statistical perspective without any broader understanding of the context of it. But if we then eliminate the use of data at all and then just basically do the gut feel management style that may have worked historically, well, we're not necessarily then taking advantage of these unforeseen relationships that may actually have a lot of information, a lot of insights that we could actually take advantage of. And so it's the blending and the balancing of being able to understand how to use data and how to still maintain our understanding of a hypothesis-driven approach to making decisions and to creating outcomes that becomes powerful. And so this is the approach that we want to start to take as we start to then think about, how do we build an AI system? How do we start to incorporate part of that hypothesis-oriented approach that we're very comfortable with, while at the same time we start to then take advantage of data? And here is a very simple framework. And again, I want to apologize. It might seem too simple and it might appear a little bit weird and wonky, but it's actually helped me a lot when I've thought about this notion of applying AI. And as I try to coach and mentor both entrepreneurs, students, technologists, business leaders alike on how to think about it. And I typically try to think about it as a three-legged stool. So to me, this becomes a very simple framework to think about the basic building blocks of an AI system. And we'll get into all kinds of details inside the course itself around all of these things, but I just want to shed light on a couple of these key issues. So there are three legs to this stool, as you can see, right? The one is data. The second are the algorithms. So where are we in terms of our ability to manipulate the data as well, right? And how sophisticated are the algorithms that we have access to? And then the third is the platforms, which is our ability to actually compute and to take advantage of the algorithms on top of the data, but in an efficient, timely, and economically feasible way. These support the problem definition. And much like a three-legged stool, which the legs by themselves, right, don't really add the value. It's the seat that you sit on that is really the core. That's the same thing that I want you to take away from this conversation. This building block has to begin with, what are you trying to do first? Defining the problem, defining the purpose of why you're even pulling these things together. So it's like a stool without a seat. It's just three legs. They don't really do anything for you. The seat is what brings this all together and actually creates the value proposition, right? The legs you need to make sure that the thing just doesn't topple over, right? So you don't have a one-legged stool. But I really want you to think about the problem definition as your starting point. And much like entrepreneurship or innovation, right? The first building block should be about, what problem are you trying to solve? What is the key market motivation? What is the customer motivation? Whether your customer is internal to your organization or external to your organization as being somebody that you actually are serving. What is their motivation? What are they seeking? What problem are they looking to solve? What are the domains of things that we can think about that we could enhance for them? Now, again, your customer could be an internal organization, or it could be truly somebody that you're serving. as part of your organization outside of the company. But it's really important to start to then think about what problem is it that we're really trying to solve for here. From there, we then shift through the legs. We start to then think about data, right? And what kind of data do we have access to? How do we start to think about the kind of data that we have, and how does that become useful to us? How do we start to think about this difference between structured and unstructured data, where structured data is something that is already very well organized. It's in tabular formats. We may be collecting it via our existing systems already. And then unstructured data is all of the stuff that is just kind of flowing to us that's not tabular, right? It's not necessarily organized in a way that is really accessible or machine readable or analyzable via a spreadsheet or a traditional type of algorithm. And how do we start to think about this entire universe of data that can then fuel our ability to think about generating these outputs and these outcomes? And that's really, really the important thing. From there, obviously, it takes a little bit of sophistication and talent to understand how do we start to then think about the engineering-oriented side of things and the platforms that we want to use. Those are decisions that should be made by the technical experts. And then obviously, what is the cutting edge of the algorithms that we can actually then take advantage of and put into practice? And a lot of these algorithms are really predicated on two things. One is on the modern world of data and the large volumes of data that we have accessible to us. And the second is this notion of machine intelligence. And so for the final few minutes, I just want to touch on a couple of things around machine intelligence, specifically machine learning. A lot of people confuse and conflate AI and machine learning. And so just very, very simply, machine learning is a subfield of artificial intelligence. It enables computers to learn on their own, and the machine learning algorithms allow us to identify patterns and observe data, to build models, and then to explain the world and to predict things without having to a priori explicitly program those rules into place. The typical example of how to think about this is to observe a child. It's based on the same concept where through trial and error and through observation and through outcome, a child does not necessarily know how to manipulate their fingers. They do that by observing over time these actions until they can refine it and hone that skill in a much more complex way as they continue to learn and to incorporate this as part of their psyche, as part of their decision making, as part of their general intelligence. And so it's this response to experiences. It's a similar type of thing that we want to then think about conveying in terms of traditional programming to machine learning based programming. So traditional programming, a computer is instructed in a very specific way to carry out a set of tasks, right? So you understand what it does, you program it. It's almost like the child. It's born with an understanding of how to manipulate the thumb and the forefinger and to do things at a high precision. And guess what? It doesn't continue to learn from that because it basically is stuck with whatever you taught it. So it doesn't actually get better over time. So if you think about a child, it first learns to pick up one thing, and then the more sophisticated it becomes, as it learns how to manipulate this particular skill set, it learns how to manipulate it with such fine precision that it can start to use a chopstick or to write. And think about that as being the ultimate in terms of precision work that you might be able to do. Versus a 1-year-old, you'd be excited if they can just pick up, the pen in the first place, let alone to even begin to write with it. And so traditional programming limits us by having the human intelligence program directly what the system can do. With machine learning, we set it up such that as it observes, it can actually refine and hone and continue to evolve those skills and become better and better at that over time. Now, this doesn't apply to absolutely everything, and the limitations and how it works we'll describe in the course because it's actually ever so slightly complicated. But that's the way to think about the difference, right? Is this ability for us to continue to learn and for the machine to continue to learn that very specific skill based on observed data and on observed outcomes that we can then say, this is what a machine learning mindset and approach is in terms of how we want to program something in an output versus a traditional programming model. So hopefully that gives you a quick sense of how to think about that. And again, if you take nothing away, what I'd like you to do, especially from a business perspective, is to apply this model. Throwing AI at something without a clearly defined problem doesn't make sense, right? So the clearly defined problem in the case that I just described to you is manipulating two actuation arms to actually pick up a pen and do something with it, right? So for example, that becomes a problem definition. Then we would think about the data, we would think about the types of algorithms that we would use, and then we think about the computational platforms and the AI infrastructure that we would need for this to actually be able to operate. Without the problem definition, throwing AI at something doesn't make sense. So it's very, very important to begin with that, then to ask the question of what data do we have, what algorithms should we be thinking about? This basically is depending on the experts. And do we have the right platforms in place for us to even be able to implement these things to extract the value that we're looking for? So a simple way of putting this into practice, right, which is going to be my final thought for you, is to apply the 6 simple questions in and around this framework. Always begin with why. Why do we believe that there is a business opportunity or a problem worthy of being solved? This is our problem definition. Begin with that why. From there, we want to start to then think about, again, thinking about this notion of data being the fuel. So without the data, the algorithms don't really have anything to act on. So what is the underlying data or the fuel that is going to be helping to drive this solution and to drive this outcome that we have? And sometimes you might say, we have this data, what questions can we ask of it? It's fine. From there, we want to then start to think about who has the expertise designed to develop the algorithms to validate the models. Do we have the infrastructure to then be able to do this? In today's cloud environment, that's absolutely prevalent almost everywhere, but you also want to validate that you within your organization have access to the capabilities that the cloud offers for you in these applications. It becomes part of your decision matrix. From there, we also want to address the how can we measure the benefits, right? It ties out again to this problem definition. So once we go through the cycle, we want to revisit the problem definition and make sure that we have the very clearly defined benefits that we can measure, such that we can then benchmark the capabilities of AI, right? And so then we can benchmark how we even proposition for it to come to market. And then we want to then address the question of timing, which is when. When should the organization make this dedicated commitment to support the adoption of this AI initiative? If you have all of these questions even roughly addressed, then the answer is now, right? And if you don't, that's absolutely fine. Let's start to think about how do we put the building blocks in place? How do we create the data strategy? How do we think about a long-term AI strategy such that we can then incorporate this is the time for us to act. And then we act with sufficient resources, with sufficient talent, and with sufficient oversight in terms of how we're going to actually roll these systems out and extract the value from them. So hopefully this has just been a very small introduction to some of the topics we're going to talk about in the course. And we're going to get into a lot of further detail, almost painful levels of detail, around not only the building blocks, but also the incorporation of best practices when we start to think about incorporating and implementing a data strategy and an AI strategy within the organization. It's unfortunately far too much detail to describe in one short webinar, but hopefully the course will provide some additional insights into how that happens.
Pedram, thank you for this informative and important presentation about AI strategy and digital transformation. As I was saying that nobody heard, before we transition to the Q&A, everybody, if you've got a question, please submit that question. We've had several come in over the presentation, but love to see some more. I want to point out, Pedrum, during your presentation, you did mention how in your course, the DDT 224 course, you did these exclusive intimate interviews with industry experts from all different industries about AI implementations and their perspective. I thought that was some of my favorite parts of the course, because you get to, when you take the course, you get to see the inside of these companies that you normally would never see. You get to see where they had successes and failures. So I just want to point that out to everybody in the audience, that the course does go deeper and richer into the content. All right, Pedram, we have gathered several questions, many questions coming in now, so thank you very much. And I've got a couple for you, so let's go ahead and get started. Let's just start with, we've had a couple questions come in about feasibility of projects. How do you apply the building blocks, the framework that you talked about, to assess the feasibility of a project? Somebody asked about the financial component of it. Can you talk a little bit about that?
Yeah, absolutely. It's funny. It's one of those situations where if you think about project feasibility, it's oftentimes overwhelming to just say, okay, well, here's the thing that we want to do, big picture, right? And we're going to throw AI at it. It might sound like I'm being extreme, but I can't tell you, almost like a weekly basis, I hear a conversation like that, right? Or somebody says something like that to me, right? Where they say, oh, we're just going to throw AI at that thing. And I'm like, wait, hold on. I don't even understand what that means. I think whether it's the framework that we talked about with the stool, or if it's some other framework that you use, I highly recommend thinking about a structured approach to being able to break down something that is as amorphous and as sometimes ill-defined as AI, and then apply it to something else that might also have uncertain outcomes without a framework. So even if you just think about those 4 different building blocks, I think the first thing is, do we have a clear understanding of the problem that we're trying to solve? And sometimes it's really, really important to look at that and say, okay, do we really need AI to solve that problem, right? And then how can we actually think about this thing that is so complex that we can't even define what the problem is? If you can't define what the problem is, right, what are you going to throw AI at? What are you going to throw your algorithms at? And so that's the first important part of it. From there, then the next question becomes, well, do you have the fuel? Do you have the data? Do you have access to the data? Do you have permission to use the data? How rich is it, and how useful and practical is it for you to be able to take advantage of that? You may not be able to address the algorithms part, which is fine, right? But it's always an interesting question to then think about, can we actually think about, the existing state of the art even being able to address this thing? Or are we, again, applying science fiction to being able to break this problem down? And then the last piece of that has to do with this element of this platform approach. And what I mean by that is when you think about a platform, you want to think about, do you have access to the ability to actually run not only the computational resources that are required and the networking resources that are required for these systems to actually operate, but also all the data management, data storage, and all the other like. And if it requires for you to have permission to use things that are on the cloud because you don't have access to those, let's make sure you do that. But I also want to make sure that we highlight, and I'm sure there's a second question on this, and I'm jumping the gun here. I also want to highlight this distinction between this platform versus the algorithms. And they're very, very different. And I want you to think about a very simple example, right? To hopefully paint this picture in your mind. So I've got friends that work in at Amazon in the Alexa group, so I understand the big picture stuff that they're doing, right? And so without disclosing any of the details, I want you to think about it from a consumer perspective. You walk into a room and then you say, hey, blank, I don't want to turn on all your Alexa devices. So, hey, blank, turn off my lights, or turn on my lights because I can't see anything and my hands are full. And that's assumed that you've got the algorithms that can do that perfectly with 100% accuracy, precision, and they do it, they nail it, they know you, they know your accent, they know exactly what you're saying. But the infrastructure takes 12 minutes for the answer to respond and 12 minutes for your lights to come on. So this is why I'm saying it's not just about the algorithms. The algorithms can be perfect, but you have to think about it in the context of the utility of what it is that you're providing. And this is where understanding the platform piece of it is equally important, right? So what level of performance does this thing need to be before the value is realized? I can't sit there with sort of 2 watermelons underneath my hands waiting for Alexa to turn on my lights when I'm walking into a dark kitchen, for example, right? I need it to be roughly instantaneous. And so this is the big picture of what we want to start to think about. And each element, each very simple element of that framework that I shared with you, hopefully at least gives you a mental rubric to think about when it comes to feasibility.
Great, thank you. We have another question. Actually, it's a number of people have asked similar questions. For someone who wants to become an AI professional, what would you recommend for them? And is it mandatory for an AI professional to be a programmer, a traditional engineer, to lead an AI-focused transformation within their company or organization? And the follow-on question was this: do you have to be a technologist? Do you have to be an engineer? Can you be a business executive? And I'm going to add one more question to that. How do you convince management that this is the right thing to do?
Oh, well, I guess I'm going to have to cancel all my meetings for the morning because this is going to take 4 hours to explain. It's a wonderful question. And I don't think it's one of those questions where there's a satisfactory, simple answer. And so I'll try to be as open and honest with you as I can in terms of just giving advice to people. First and foremost, I think that there is different skill sets required for thinking about being somebody professionally involved with AI. There are people that are experts when it comes to understanding the technologies from an algorithmic perspective, right? So how do the algorithms actually come together? What is the cutting edge, and how do we apply those such that we can then sort of fuse some of these technical components together to deliver results, right? It's a very, very sort of scientific approach, if you will. There's also the other side of that, as I just mentioned, literally on the feasibility example, which is that there's an engineering approach to this. So you don't need to be an expert in the algorithms, right? But there is a huge amount of work that's required from an engineering perspective to bring these systems to life in a stable, repeatable, consistent way. And so there's an entire notion of how to think about building the infrastructure for these systems to actually come to life and to be used in a practical setting. So I think that there's a spectrum of things that one could do from a technical perspective. But at the same time, I don't think that that's sufficient, because it's not just about the technology, it's also about the application. And so being versed enough to understand the capabilities of the state of the art, having the empathy to speak with the technologists to understand what are the current capabilities and what are the current limitations. We'll talk about some of those in the course, obviously, but they're going to be case dependent. They're going to be domain dependent. So speaking with some people that are experts in the field in terms of just being able to define what those boundaries are and being able to understand what can be done with those. You do not need to be an expert in computer science or AI to be able to drive some of those decisions and some of those business-oriented outcomes. So I actually think that the role is multifaceted, and it's going to be a multidisciplinary team in this whole AI ecosystem to actually create useful outcomes. So I personally think that it's all about understanding where your skill sets are today and how best you can leverage them in this context. Are you very good at framing questions? Are you very good at helping define consumer problems and customer problems and being able to translate that back into systems? Are you good at just the algorithms, and this is sort of where you want to go and maybe go back to grad school, get a master's, or continue to refresh on what you're already doing? Absolutely fine. Or are you good on the engineering side of it, but you want to become better versed in terms of how does that engineering angle orient yourself towards this? And I also want to then say that this is a huge spectrum, because there's a lot to do with data engineering and understanding how to even manage and manipulate data that is also part of this broader ecosystem, right? This broader digital ecosystem. So I think that there's a lot of different touch points there. So do you need to be a technologist? Absolutely not. Absolutely not. I think you just need to be open-minded. You need to be empathetic in terms of understanding who else you need to speak with. You need to have the approach of being willing to work in multidimensional, multifaceted, and really multidisciplinary teams. And you need to have the appetite to stay relevant and current, because this field is changing almost on a daily basis. And that's that piece of the Dunning-Kruger curve that I was mentioning. The first instances of AI have been around for 70 plus years. And for people that have been in this space, they'll tell you, right, that we've had these winters of AI over time where the interest on the field has sort of completely dissipated away, and no one's interested in it anymore because there's a lot of hoopla and a lot of hype, and then all of a sudden nothing happened, and so everybody just basically shunned it and said, well, look, that's not useful stuff. And all of a sudden then there's another emergence of that, and so on and so forth. I think what makes things different today is understanding that there's multiple different things that are coming together. And this is the number one way of convincing management, is to say that historically we haven't had this confluence of trends simultaneously coming together. And so as a result, it's not necessarily that it's all new math or new algorithms, right? A lot of these concepts have been around literally for decades. But it's around the fact that now we have data that was unimaginable, right? We have access to technical talent coming out of undergraduate programs that's unimaginable in terms of their insights and expertise. We have access to infrastructure that would have cost us hundreds of millions of dollars that we can then basically have a credit card swipe we had access to. And so all of these things are coming together for us to experiment, and experiment relatively cheaply. And so unless there's a core desire to continue to live in the past, I think management should be convinced by very simple shedding of the light of these underpinning currents that are all coming together to support a new ecosystem and a new evolution of technology that can get applied, and not to oversell it, to get people enthused about it, to get them to understand that there's a difference today versus literally 10 years ago. That's how quickly everything has changed. But then not to promise these crazy conceptual notions of what it can do, and then set yourself up for, impending failure. So that to me is the best way of doing that. Get people excited, get them aware about what's happening, why now is an interesting time to do that, and then a few small experiments that are cheap to conduct and are worthy outcomes to showcase what can be done. So that to me is a logical approach, unless the CEO of your organization has already said, hey, here's the next $2 billion we're going to devote to this, and say, gung ho, go for it. But otherwise, I think a very measured approach to getting people bought into very low cost, high fidelity experiments that you can run that are relevant to your organization, I think are fantastic starting points.
Excellent. Thank you. Great advice. Let's see here. There's a common theme that's coming from a number of questions, and it's weighty, and we only have a few minutes. So, but there are questions coming in talking about emerging economies and the role that AI will play with those economies and how it will affect those people in those areas and those companies and organizations and countries. Can you talk a little bit about that? I mean, the questions Absolutely. Are coming from different perspectives, but I mean, that's the common theme.
Absolutely.
How do we address that?
Yeah, there's so many different perspectives around a wonderful question and a wonderful topic area that I agree a few minutes doesn't do it justice. Let me shed light on it from two different perspectives. The first is the workforce perspective, where you say, well, look, if we just take a high level view of emerging economies, you can say, well, that they're predominantly in, let's say, labor-centric markets, right? Not necessarily information-centric ones. And so what are the impact if we have less reliance on labor? And I've heard it said by a lot of experts here as well, right? So I can't take credit for this, but the world has so many problems and so many opportunities to make it a better place that talented people or aspirationally interesting people will always find work. And there's always going to be an opportunity for us to continue to apply technologies to do things better. It's almost like saying, well, look, we're so used to doing things by oxen and cattle that, you know, we're worried that if we buy these tractors, they're going to make us obsolete. Well, that's crazy. If you don't buy the tractors, you're going to be obsolete, right? And so you can see this sort of this adoption of technology happening over time. So, and we'll talk about an example in banking in the course itself, but the notion of job loss because of automation, because of AI, is a real one. And we do need to transition the workforce to being able to do something different than what they were doing today. But it also unlocks an opportunity to do things that are much higher value as well. Even in very specific ecosystems, like, for example, in farming, right? If we can actually create better food using AI, right? Better crops, higher yields, you can start to then think about a much broader ecosystem, even in around agriculture, that you can then start to think about. So I think the fear of job loss is something that a lot of people haven't been able to completely wrap their head around. And I think if we look at it historically, yes, it's true, very specific jobs will be lost. Those same jobs will have to change and morph. But education actually unlocks a whole new set of opportunities to build on top of new professions that we can create using technology. One very quick thing I will say on the other perspective is to also look at ecosystems that don't have a lot of legacy. And so if we actually take a look at Africa and what's going on in terms of the banking ecosystem there, or even the digital ecosystem, and how quickly you actually end up leapfrogging technologies and advancing the entire population because there's not a legacy infrastructure that you need to then pay for, it's actually a pretty remarkable way of freeing yourself up. If you've invested billions and billions, if not trillions of dollars into infrastructure that is slowly becoming obsolete, and you can then basically say, well, we don't need any of that stuff because now we can leapfrog it because of the technology and just adopt a new one, which is way cheaper and also provides all the things that the previous generation did. That actually creates a very amazing ecosystem and a proving ground for new technologies that you don't need to then go convince the existing legacy entrenched mindset that you need to go about it that way. So I actually think that emerging markets are an amazing opportunity for advanced technologies that are either data-centric, analytic-centric, or AI-centric.
Awesome. Thanks for taking the time to answer that question. I know we're running a little bit late, but I do want to thank you for your time today and your presentation, and taking the time to answer that last question is very important. And it's in the Stanford philosophy of making a difference in the world. I want to thank everybody who stayed on all the way to the end. There actually is still a very large number of people that stayed with us through the entire webinar. So thank you all for joining us today. And with that, I want to wish you all a great rest of your day, wherever you are in this world.